Hello, we are the Natural Fiber Composites team. We worked with palm fronds from University of West Florida in Pensacola, using palm fronds and trying to develop a material profile for them and a novel use and processing method. My name is Carl Kweisman, and let's get into it. So first, our scope and customer requirements. Our goal was to find a novel use for waste palm fronds that are common in places like Florida or other tropical areas, with the goal of using what would otherwise be effectively yard debris trash, with no real end-of-life sort of purpose, and goal of being a sustainable, low cost, and a lightweight, stable, cheap alternative to materials like bamboo or other woods, and using them to displace a market that already exists. And so our scope was mainly surrounding finding a new use for them and getting a basic profile of material testing to learn more about the material and what it could potentially be used for as well. First, though, we did some larger scale analysis, like a life cycle analysis, and David's going to get into that here.
As Carl mentioned, with our engineering specifications, we were comparing our material to bamboo, which is a competitor wood composite material, to palm fronds. And so looking at bamboo, it requires a significant amount of water to grow and also uses chemical treatment during its growing process to prevent insect and fungal disturbances. These chemicals pose a risk to both humans and its surrounding environment. As for the palm fronds, as Carl also mentioned, they were collected and sourced by the University of West Florida, and they were rather collected by naturally shedding from trees rather than farmed like bamboo traditionally is. And with that, the palm fronds have minimal treatment prior to manufacturing, other than some drying processes prior to manufacturing. And following this, the team conducted a life cycle analysis utilizing OpenLCA, using a 1 cubic meter of material. And from there, we noted that the palm frond material had a 43% reduction in global warming, a 90% reduction in terrestrial acidification, and a 37% reduction in human carcinogenic toxicity. Following this research, we found that the palm fronds were indeed a more sustainable material.
All right. Before we could get to doing the actual material testing, our team first had to process the raw palm fronds that were shipped in from Florida in order to make boards. The process that we developed that worked the best was to first remove the sharp edges on the sides of the fronds using a bandsaw, as indicated by the red lines on that image. In the image in the middle, you can see the now cut palm fronds that have been then run through a planer to create two flat surfaces. Once those surfaces were made, we would run them through a table saw until they met the exact dimensions we needed for our test. In this case, they were a 1/4 inch by 1/2 inch. And in order to glue them up into a flat board, you can see on the right that we have 2 aluminum plates that we are using to clamp down the boards together in order to create a flat piece. Here's the picture of the board after it came out of the clamps. It's pretty flat, but we needed to run it through the planer in order to get to a uniform thickness. So that's pictured on the right. After that, we were able to cut up the board into the sizes we needed for our test samples, and then we put a layer of fiberglass over the top of them and then added resin to the top of the fiberglass in order to get the test samples we needed. And now I'll pass it on to Scout for the material tests.
So the properties to be tested were planned to be hardness, tensile strength parallel to surface, and static bending. And the properties were tested according to ASTM standard D1037, which is the standard test methods for evaluating wood-based fiber and particle panel materials. Due to equipment availability, we were unable to test hardness, and our specimen sizes needed to be reduced to fit inside of the equipment. 4 sets of specimen were planned to be tested 3 times each. So the bare board, the 4-ounce fiberglass composite, and the 6-ounce fiberglass composite. We were also going to test a carbon fiber composite on the bare board, but we did not end up having the time available to us to manufacture those boards. So specimens from each group were cut from the same board to reduce variability, and as you can see on the right, we had a dimensional analysis to determine how we would cut those specimens out of the board. So these are the testing results. For the bare board, the average tensile strength ended up being about 3,800 pounds per square inch, and this increased steadily for each of the composite board specimens, and it does fall somewhere in between the tensile strength of a balsa and a bamboo, which is pretty much what we were expecting. For the 3-point bending, the result average PSI for the bare board was almost 2 million PSI, which is also in the range that we were expecting. And it did steadily increase for the 4-ounce fiberglass, and then we got strange values for the 6-ounce fiberglass, which could be due to the variability in our wet layup and issues with the resin. I'm going to hand it over to Jensen.
So I would like to now outline, out of all of our challenges in the process, one of our most major ones was the moisture content present in the palm fronds we received. Florida's humid. Palm fronds are inherently a damp sort of wood product, and by the time they were collected and shipped over here, they did not dry out. So we had water present in the shipping box, lots of water still hydrated within the palm fronds themselves, and so we worked to come up with a solution to that, and that was our drying box, because we didn't want moisture in our final planks. We took our raw palm fronds as well as some processed palm fronds and created this drying box for them. It consists of just a wood laminate box that we altered with some air circulation, holes at the bottom and the top, a heat lamp that we attached to the bottom to provide warmth to assist in drying, as well as a small Arduino controlled fan at the very bottom that, along with a outlet timer, we had both that fan and the lamp on a cycle that turned them on and turned them off at various points throughout the day to keep some heat and airflow through that box, but not enough to cause any danger of burning the palm fronds or the box itself. So this proved to assist somewhat in our drying process as well, where any fronds we put in there for several days came out significantly more dry than any that were just sitting on the outside. So that was good to see, and we hope that this box is utilized further in future capstones, as well as a rack was ordered and assembled that we were able to put palm fronds on outside of the box to allow them to dry as well. And our final product that we ended up making from these palm fronds and palm frond boards was a set of 3 surfboard fins. Now these go on the bottom of a surfboard to assist in controllability and just keeping your board straight, and we luckily got the chance to partner with some OSU alums down in downtown Corvallis that actually have set up a surf shop that they're trying to sort of get into the works. Now, this surf shop is specifically interested in sustainability as well. They're called bunny boards, and they've even had experience in building or at least utilizing wood-based surfboard fins. And so we got the chance to tour down there. They introduced us to the staff and some of their processes, which included the direction of the board layup for the surfboard fins themselves. They gave us specific CAD drawings of the fins that we were able to model and then cut our boards out into the shape of, as well as the surfboard attachment plastic piece that you can see on that middle fin there, where we designed our fins to fit into. And so then past that, we just went ahead and laid up these fins, and that was the conclusion of our project. We would like to thank Joe Piacenza and the rest of the OSU staff that assisted in our project, and thank you for listening.